Okay, in this problem, we're going to do problems 11 and 12. And I'll show you why we're grouping these two together. They kind of go together. So here's our review sheet. And 11, it's kind of like FOIL, but instead of foiling two binomials, we're multiplying a binomial and a trinomial. So it's a little different than just foiling two binomials. And factoring is the opposite of basically multiplying. So these two kind of go together. All right, so let's take a look at our work that we're going to do. Okay, so with FOIL, we take the two first and then the two outer. But with this, because there's a binomial and a trinomial, we multiply the first term times each of the terms in the second set of parentheses. So we're going to take 7 times 49, and 7 times 49 is 343. And p to the first times p to the second is p to the third. And so now we're going to multiply 7p times 7p. 7 times 7 is a 49. 49. And p times p is p squared. And then 7p times 1, that'll be plus 7p. Okay. Then we're going to multiply the second term in the first set of parentheses, and we're going to multiply that times everything. So -1 times -49, that's a -49p squared. And -1 times 7 is -7p. And -1 times 1 is a -1. All right, so now we combine like terms. And here we have a p to the, start with the highest exponent. We have a p to the third. We don't have any other p to the third. So this will be 343 p to the third. And we mark it. Now we look for p squared. Well, we have a 49p squared. So this will be plus 49p squared. And we have a -49p squared. -49p squared. And there's no other p squared. So now we look for the p's. We have a plus 7p and a minus 7p. So we mark those. So here we marked everything except for the only thing that's left is a -1. Okay, so now we combine like terms. Well, there's nothing to combine with the p cubed. So we just bring the 343p cubed down. We got a positive. If the signs are the same, we add. If the signs are opposite, we subtract. So here we have two p squares. So we have a positive 49 and a negative 49. Well, 49 minus 49 is 0. They cancel out. They go to 0. And so now we look at the p's. Well, we don't write plus 0p squared. We just leave it blank. We have a positive 7p and a negative 7p. 7 minus 7, that's 0. And so the only thing left is a -1. And this time we only have 343p cubed minus 1, and that's it. And we're done with number 11. Okay, so now we're going to look at number 12. And we're going to look at factoring. Well, before we do that, let's review factoring for a moment. So if we want to factor x squared plus bx, this is ax squared plus bx plus c, or ax squared minus bx plus c. If the c terms are positive, then the c term is positive, then the signs are the same inside the parentheses. So factors for this first one is going to be x, because it's plus and plus, will be x plus, we'll make this C1, and x plus C2. For this next one, because it's a plus, the signs are the same. So this will be x and x, but this time the middle sign is a minus. So we can't put plus and plus because the middle sign is a minus, and the signs have to be the same because the C term is a minus. So we put minus and a minus. So this will be C1 and C2, because in negative, if we FOIL it, negative times negative will give us our positive. Okay, so that's when the C term is positive. Now here, if we have ax squared plus, the middle term is a plus, but the C term is a minus. Also, if we have ax squared minus bx minus c, because the C term both C's are minus, then the signs are going to be opposite signs. So this would be x plus C1 and x minus. So the signs inside the factors are the opposite. And it doesn't matter if it's plus or minus and a plus. So I'm going to change this one, make it x minus C1 and x plus C1. My marker's running out. Okay. All right, so let's take a look at our problem. We have x squared minus x minus 12. So because the C term is a minus, the signs inside our factors are going to be opposite. So we start with putting our variable, since our variable is x, and it starts off in the beginning, then we put our variables in the beginning of our factors. The C term is a minus, right? So the signs are opposite. So you can either put plus and a minus or a minus and a plus. It really doesn't matter. Okay, now we look at factors of 12. So factors of 12, we start with 1. 1 times 1 in any number is that same number. So we always have 1 and 12. 2 and what give us 12? Well, 2 times 6 gives us 12. So that's 2. And that times 6 is 12. Well, what else? If we go 1, 2, 3, you're always going to get all of them. So we go in order. So 3 times what is 12? Well, 3 times 4 is 12. So now, because the signs are opposite, the pair of factors are going to subtract to give us the middle. Any one of these will give us 12, but only one pair will give us the middle number. Well, what pair of factors will subtract to give us 1x? That can only be 3 and 4. And since 4 is the larger, and this is negative, we put the 4 with the negative because it's larger. And the 3, so our factors are x plus 3 times x minus 4. Well, if we FOILed it, if we want to check it, you always want to check your factoring just to make sure. So you do that by FOILing. X times x is x squared. Two first terms, the two outer terms, x times 4 is a negative 4x. And then the two inner terms, 3 times x is plus 3x. And then the two last terms, 3 times negative 4 is a negative 12. So we combine like terms, we got a negative 4x and a positive 3x. We get x squared minus 1x, negative 4 and 3 is 1, negative 1 minus 12. Well, that's what we started with, right? The middle term for our check is the same as the middle term, and that's really what we're checking for. So if you just did the two outer and the two inner, you could get that middle. Since this checks, then this is a good factor. And whether it's x plus 3 times x minus 4 or x minus 4 times x plus 3, that really doesn't matter. What does matter is that the signs are in the right place. The negative is with the 4 and the positive is with the 3. Negatives with the 4, positive with the 3. Okay, so since multiplication is commutative, it could be either way. And that's our two problems for problems 11 and 12.